Oh shit. It's tutorial time! Hello? It's way too loud. Hello? Okay, this should be working now with decent audio, hopefully. Last time was a bit low quality, so this should hopefully be substantially improved from then. So today we'll be doing the same session as we did last time about chess, but I'm going to go way slower this time so that we can get the details more ironed out. I understand a lot of people last time might have been spooked by the speed of the whole thing, and that's fair because we did cover a lot of grounds. So today we might not even get through the whole app, but I'm going to make sure that we go slowly and that everybody can hang on. And then also coming up, to be announced when, but I'm planning for probably Monday, we're going to do an assignment 1 catch-up session where it's going to be kind of an open forum with questions regarding assignment topics, and I'll also be going into things like how to properly run debuggers and this kind of stuff, which I can briefly do as well. Today I can touch on the how to debug your code, but I will go into much more detail on that catch-up session. For now, I'm going to send you guys the written version, like the written doc of today's session, which is also posted to my courses. And that should help you with just kind of a read-along if you prefer that format. Here is the link in the chat right now, and you're welcome to access that and take a look. It might help you out with some of the concepts. The main concepts we'll be going over today are going to be turning chess into a game. And we're going to use some object-oriented programming to accomplish this. So a couple rules we'll need to know about chess. We're doing a simplified version. We're not going to do like a super detailed game of chess with all these rules. We're not going to write like an AI to play it or anything. We're going to do a pretty simple implementation. It's played on an 8-byte board. There are pieces, and each piece has different rules as to where and when it's allowed to move. As we all know, like every piece has different rules which dictate where it can go. Then we know that players take turns depending on where they're going to move, how they're going to move. Then we also know that a player can kill other pieces, and you win by trapping the enemy king. The main concepts we'll be going over are, these are just some extra practice stuff. You can look at that for a second if you want to. Not too important. The main concepts we'll be going over is abstract classes and inheritance. So before I go into much of the chess application, first I'll discuss what is an abstract class. Can anybody give me like their explanation of what they understand an abstract class to be? All right, so if you did have your explanation, you're welcome to speak up. Class without implementation, says Unami Dima. Well, yes, that's correct. But what do you mean exactly by class without implementation? All the subclasses will inherit the methods. Yeah, okay. Well, does somebody want to come up on the mic and try to give like an explanation of why an abstract class might be useful instead of just a regular standard class with everything implemented? So why would we want to have a class where some things are not implemented? And what does it mean to have things implemented versus not implemented? Yeah. Yeah, that's a very good explanation there, and just to reiterate, in case the recording didn't capture that, because I have a weird setup here, it should capture it now, but I don't know if it did there. It is that, like in the example from the lecture with the shapes, that some classes may need to have the same methods, but need to execute them differently. Now, can we see a parallel to the game of chess as to how an abstract class might be useful? Like, where in the game of chess might we benefit from having this abstract class going? Is there any part of like the game that we think could benefit from it? Is there any way that the abstract class could make our life easier in programming a chess game?
Could we
Are
have
there?
an abstract class for each, like for the pieces, and then a subclass for each type of piece?
Yeah, that would be a very good reason why. And could you tell me why maybe that could be helpful for us? So why would it make our life easier to have it designed in this way?
We would have like common methods, the fact that the pieces can move, they can eat other pieces, or they can like die in a certain way,
Yeah,
but they
exactly.
can move in different ways.
Yeah, that's right. So we have things in common and we have things that are not in common. So are there things that perhaps that we could implement right in the abstract class that every piece has in common? And are there things like which things do you say would be specific to each piece, and which things would you say would be more specific to, you know, the general abstract version of the piece?
I think maybe I don't know when the pawn gets to the end of the board, I don't know what it's called. It upgrades or something.
Yeah.
So that would be something in the pawn class, but not necessarily in the piece class, the abstract class.
Sure. And when we talk about something that's in the class for the pawn but not for the piece, what would we name that? Would that be an override? Would that be like an overload, or would that just be like some part of the class?
I think it will be just part of the subclass and not the superclass.
Yeah, that's right. And then we know that it's not an override and it's not an overload because it doesn't actually go over something that was in the superclass. The superclass being piece, the subclass being the pawn. We know that if we have that, then the pawn will have its properties that are not common to piece, so they are not overridden. That's what override means. And those are some of the key terminologies that we're going to be seeing today. Those are abstract. Then there's super. So the use of super is that if we're in this subclass like pawn and we need to access a method of the superclass, which is piece, we can use the super call. And then of course we have extends, which is just this notation we use to create this relationship between the classes. And we have override, which is what happens when we have something in the superclass and we want to replace its functionality in a subclass. So again, here's some more details of the important terms, and the written doc is full of these, so I won't keep it up for super long. This will be something you guys can read more in detail in the docs there. Now if I transition out of the slideshow and transition right over to the regular screen capture, we could get started with seeing how the implementation looks. And I'm going to go much slower on the object-oriented stuff here, but just like last time, I will just, for like the mathy parts and the parts that don't have anything to do with what we're really learning today, I might skip through those pretty quickly. This is just a project from last time. So I'll create a new project. We'll start off fresh. And I'll introduce you guys to some of the notations around abstract classes and around inheritance and around all this stuff. And just some of the coding practice that goes along with it. So our new project, let's call it chess2. Yeah, Java 15, nothing selected, and we'll call it chess2. Finish that up. We've decided now, right, we need an abstract class for our piece. And we need a class for each of our pieces. So to do this abstract class thing, what we do is we create a Java class like normal. I'll call it piece. But now, instead of just saying public class, I can throw an abstract here. And this lets me do some special things. Now, as a class which is not abstract, if I just keep this as a regular class piece, every method I write has to have an implementation. What's meant by an implementation is there has to be something in the curly brackets after the method. So if I say public, say void move, and let's say we want to move to the coordinates int x and int y. We want to move the piece from wherever it happens to be to int x and y. Now we're not thinking too much about this method yet. We're not writing it yet. I'm just trying to show the syntax. If I have these brackets here, it's all good. But as soon as I try to just declare that there should be a method like this, you can see that it's not letting me do that. It's saying that the method has no method body. That's the difference between an abstract method and a non-abstract one. You can even see here in the suggestions, it's saying or missing method body or declare abstract. So it's saying that unless this method is abstract, I have to fill it in. What this means to us is that an abstract method is just a method which has no body. It's a method where whatever is supposed to be written here isn't. And it's just describing that everything that inherits from piece must override this method. Could somebody tell me what I mean when I say everything that inherits from piece must override the method?
we have to create a method in subclass that has the same signature?
Yeah, that's correct. And when we say signature, of course, what we mean is that it has the same public, it has the same return type, so it's this void. It has the same name, and it takes the same input types. So they don't have to be called int x and y. They can be called whatever, but it has to take 2 ints as input. So here, our method signature is so it's public, returns nothing, returns void, named move, takes 2 ints as input. Right? That's our signature. That's what everything that overrides this must have these properties. Right? And that's how we know that it's overriding it. So when we create an abstract method, again, this method doesn't exist in our abstract class. Rather, it needs to be overridden. So now if I name this class, instead of a class, I name it an abstract class. I just add the abstract keyword there. Now it actually lets me have this method with no body if I also type abstract on the method. Now the reason we call it abstract, it might seem strange, like, why is this word here? What that means is more so that piece is the abstract idea of a piece. This is not defining any specific piece. Abstract quite literally means that it's defining the abstract notion of what it means to be a piece. Just like how, let's say, our class is defining a specific piece. It's saying that, say, the chess piece, the pawn, has certain rules. The abstract class piece is saying that the vague idea of a piece is here. And we know that every piece should be able to move in some way. And our method to signature describes that a piece can move from wherever it was before to a coordinate in x and y. So that's what the abstract word means. It means that rather than defining the exact details of some sort of object, we're defining the ideas that apply to all objects of its type, or all objects of this nature. So here we're saying that all chess pieces are able to move to a specific x and y coordinate. But how it is that they do this movement, we don't know. It depends on the specific piece. But our abstract class also has the ability to act as a normal class. So we know that every piece has stuff in common. Now, what's something that you would say every piece has in common? What's something that no matter what piece it is a property that's inherent to every piece?
The position?
Yeah. So we can have our position. Let's call it int x comma y. Now the notation here is I'm declaring 2 variables in one line. I'm just saying that there's going to be 2 variables of type int, and then x comma y just says that x and y are both going to be ints. You can only do this if you're not declaring what the value of them is. Well, you can declare their values too, but you can do this very short notation without the equal signs, and you don't declare their values. You can't say int comma x comma y equals 7. Can you? Oh, actually no, you can, but you can't give them like it's not the same notation as int x equals whatever, int y equals whatever. Then yeah, you can eat another piece for sure. So, but eat another piece, is that really different, like notably from move? Because in chess, when you move, if you just move to the same coordinate as a different piece, you're eating it. So do we really need to have a separate method for that? Or do you think move could be, move and eat could kind of combine together into the same method? That's a design decision. That's nothing to do with the object-oriented programming stuff. So yes, technically we could have a method for eat. That's true. But I think that to simplify our design, we can just say that when we move and whatever we're moving to is a piece, we can eat it. And in fact, to simplify this, we could also say, let's say Boolean is eating, and that will determine if whatever position on the coordinate we're moving to has a piece. So then we can kind of move eat inside of move, right? If that makes sense. Now, there are a couple more properties we could do. We could say which side the piece is on. So we could do a Boolean. So we can say Boolean side, maybe. But that code is not as readable as some alternatives. So what I can do is I can declare what's called an enum, which we saw in a previous tutorial with the snake. And I'll call it side. COVID. All right, we have an enum for side. And here I can have white or black. And we just use this enum because it makes our code look a little bit prettier. You know, instead of saying our piece is true or false, we can say our piece is, white or black, and that makes it a little bit easier just on us to read. And that's about it. So we'll say side. Right, that's also a property that our piece has, which side it's on. And then that should be good for our piece properties, right? But also, since we have an abstract class, we are also able to specify our methods. Actually, we don't just have to specify what is here. Is there any latency? If you mean in the chess game, I mean probably not in this stage. If you mean in the stream, probably yes. It's because I'm using Zoom with a weird setup. but it should be only a couple seconds. So here, yeah, we've got int x, y, and a side. And since we have, well, this piece, and we have all of its properties, we also probably want to know if it's dead or not, so I can just keep that. So boolean is dead, and that should be about good. But now, since we do have this, this abstract class, we should also be able to declare normal methods. An abstract class can have methods in it, which are just like the methods in a normal class. So we can have a method for when this piece dies, so public void, let's say kill. And this could be a very normal looking method. This one can say is dead equals true. This dot x is equal to, let's say, -1. And let's say this dot y is equal to 1, or -1 as well. So it just goes off the board and it's dead. So we can see how like this normal method has a body. It's all completely standard. And it's just like a method in a normal class. So we don't care that it's abstract because every piece dies in this exact same way. And maybe if there's like the king and we want it to die differently, we can override that. And we'll see that when we get there. But so far, are there any questions about the general structure of this abstract class?
Should we have a status of being attacked?
We could, but do we have like necessarily a design requirement for that? Is there anything that the piece will behave differently as when it's being attacked?
For the king, it's special because if the king is being in the status of attacked, the king must move. But for the others, I don't think so.
Okay, and do you think that there's some kind of trick that we know about where we can do something especially for the king and not have it apply to every piece, right? Because when we say the abstract class piece, what we mean is this is something that applies to every piece. Everything that goes in this abstract class should apply to every piece on the board, not just one of them. So is there anything we know, like any of these techniques we know, that we can do inside of the, let's say, the king class to make sure that that has that state tracking, but the other ones don't? Oops, I just didn't transition the title thing there, so did that now. But yeah, is there any trick we know? It's okay if we don't. Well, the trick we could use for that is, it's called overriding, or it's just not even overriding. It's just adding that to our class. So our abstract class, it defines what's the minimum. It defines what's required for this piece class, right? When we say every piece must have these properties, we are not saying that these are the only properties the piece can have. So when we write the king class, nothing is stopping us from adding that extra functionality in. And that can make our design a lot easier because, especially, go ahead.
Yeah, I mean, firstly, before you asked me this question, I thought that it was the same for all the pieces. But after you asked me that question, I thought that it was just specific for the king. So I thought that you are reasonable to say that we may not need that private attribute of is attacking.
Yeah. All right. Then yeah, we could add it to the king. And we can add it to the specific class that needs it. And we'll see that when we implement this abstract class. Because again, an abstract class is just a set of requirements. We don't necessarily need to, we're not required to have only these things. We're just required to have these things in addition to whatever else we want to add. So now I'm going to just add in a couple other methods, which should be very simple. So I'm going to add an abstract method for getSymbol. Now this one is not really part of chess. It's more part of how we can make the graphics for the game. So public abstract string getSymbol. And what this method is going to do is it's just going to return this symbol that represents the piece. It's nothing that's complicated. It's just another abstract method. In fact, I'm actually not even adding this for the tutorial. I'm adding this so I can make the graphics. And this is going to say that each piece must have a symbol, but each piece has a different symbol, so it is abstract, right? That also makes sense. It's just a second example of what an abstract class or abstract method could be. It doesn't have to be complicated like move. It could be something as simple as like every class has a symbol or any such thing like that. And it's abstract. But we could also have just a field for symbol. But the field for symbol might not be as good, because if we have a field for symbol, that means that we could change the symbol of a piece while we're playing. And then, you change the symbol of your king to something else, and then your enemy won't target it, and that's kind of like, a bit of a hack. We don't necessarily want our field to be a symbol. We want it to be like this. So now, there are a couple other methods we need. We can just do getters and setters. Now, a very nice thing about this IDE, if you want to use IntelliJ, is that you can generate code. So if I click code and then generate, and then I do getters and setters, I probably want a getter and setter for the side. I probably want to have a getter for dead, but I'll do that later. Yeah, so I'll just do a getter and a setter for side. Now that has a getter and setter. Now I can also generate. I just do code and then generate, or alt insert as the hotkey. And I can do a getter for the dead boolean. And now for my x and y, they're not private, so I'm not going to give them getters and setters. And in fact, this one should be private. So the things that are not private, I don't care about getters and setters. And then I'm also going to generate a constructor. So we all are familiar with the constructor, right? Are there any differences that you guys know about for a constructor for an abstract class compared to a regular class? Are the constructors the exact same for abstract classes, or are there differences? Because remember, a constructor's job is to create an instance of the object. Is it possible to create an instance of an abstract class?
No.
It's not. So can we logically have a constructor?
It has to be different, but I'm not sure how.
Well, yes, you might think so. It's logical to say that it would be different because we can't instantiate it. But that's actually kind of like a mind trick. You don't have to do anything differently, because although it has abstract properties, like move and like get symbol, it still has normal fields and normal methods too. And we still have to deal with these normal fields like with a normal class. So what our constructor is responsible for is dealing with everything that's a property of our abstract class. Right? We don't necessarily need to handle the abstract stuff, but we do need to have a constructor. And although we can't instantiate an abstract class, there are actually reasons why we need to use this constructor. Could somebody tell me a use case for the constructor of an abstract class? Like, why do we need one? When we create a class that extends our abstract class, right, we don't have access to the private fields of our abstract class. If you extend piece, the class that extends piece will not have access to this private boolean is dead. And although it will have access to side and int xy, it still might not work completely right. Well, it still works right, but it might not be necessarily good practice to set those in the superclass because you can't see the fields. You just know that they're there because they're part of the superclass. So our constructor for our abstract class has to deal with all of the fields of our abstract class. And then we call it in our subclasses. So when you create the constructor of a subclass, when you extend something, how does that class look? Is the constructor different in a subclass? If you extend a different class, do you have to do anything special in your constructor? I'll just generate this one here. I'll select those things and it'll generate it. It's very simple. I'm just saying that, and then is dead is false. Right. So this is my constructor. But do we have to do anything special in the constructor of a subclass? So when something extends piece, is there anything that has to be in the constructor differently from piece? Well, if we don't know, we could try it. So why don't I try to create a class now that extends piece? I'm going to create one. I'm going to call it, say, pawn. Yeah, I can start with the pawn. And I'll say extends piece. Now, this is going to be red, and it's saying that I must implement the methods. Sure, I can do that, but I also need to do another thing. I also need to create a constructor. So let's say public pawn. Right, and then what does this say? It says there is no default constructor available in piece. So it says I need to insert super. So can somebody tell me, why is my IDE telling me I must insert super here? What's going on here? Why is it not letting me just have an empty constructor? What's going on here?
Is it to instantiate the fields that we're inheriting?
Yeah, that's right. Because when we have pawn, right, we don't actually get these int x, y, and the side from anywhere. They're not going to magically appear for us. We still need to supply them to create a pawn. Because although every piece has these int x, y, and this side, it's not like when we have a specific kind of piece, we know what those are going to be magically. So we still need to get those from somewhere. And that's what super is doing. What super means is that it's saying we need to do something with the super class. And by just doing the super with the circle brackets around it, like it's suggesting, we're calling the constructor of the super class. Now, when it says there's no default constructor, that just means there's no constructor in piece, which takes no arguments. If there was a constructor in the piece class, which took no arguments, you don't have to put it. Or I guess if there was no constructor that just didn't exist. If you have a constructor, you have to put super. So if I place the super call, it's going to call the constructor of piece. And this is why we needed the constructor of piece in the first place. We need piece to have a constructor because if piece doesn't have the constructor, we can't set its fields. And if we can't set its fields, when we create something that extends piece, we can't have a constructor there, right? So does that make it kind of clear why we need to have a constructor in a class where we might not be able to instantiate it directly? So again, piece is abstract. We can't create a piece just by saying piece p equals new piece. We will get a compile time error because it's abstract. It doesn't have everything defined yet. And my question was, why do we have a constructor? Is the constructor useful in an abstract class? Again, we cannot instantiate an abstract class, so why the heck do we need this? Well, the answer is we have the fields here, and we need to set the fields. And then when I have a subclass of this, suddenly those fields are not up here. I don't have this int x, y. I don't have this boolean is dead. I can't see them because they're part of my superclass. So for me to properly set those fields, I have to be able to have access to the constructor of the superclass. And that's why we have constructors in abstract classes. It's so that the fields that are part of the abstract class can be set. Now, for my arguments, I probably want the same ones, right? Int x, int y, side. And then I can just supply those to the constructor. I can say x, y, side, and now it's set. So now, when I create the piece, here we are setting the properties, setting the fields of the piece part. So the superclass is instantiated. All right, so does this syntax make sense to everybody? Super here in the constructor of pawn calls the constructor of piece. Are there any questions surrounding this whole dynamic here with the extension and the super and all this? I know it's a lot of new terminology. Okay, so I'll assume that this is relatively clear, and if it's not, you're welcome to interrupt and ask. I know there's some latency, so if I'm already moving on and you gave your feedback before I could hear, then sorry, but you're always welcome to speak in the chat and speak up if something is unclear. So that's the super notation. So go ahead.
If we have to instantiate the subclass in a different way, what should we do?
Can you explain? Sorry, go ahead.
Using super means that we are instantiate the subclass in the same way, right?
Mm-hmm.
So if we want to instantiate the properties in a different way, using super, for example, to set the status, in the abstract class, it always set the one property to be true, I think, if we want to set that property to be false, what should we do?
Okay, I see your question. So you're saying here if isDead is set automatically in piece, right? We don't have control
Yeah.
over it. But in pawn, I am not able to set that in my constructor call, right? Well, there's a
Yeah.
couple ways. I could add this argument. I could overload my constructor. You know, overload means I have extra arguments, so I could put a second constructor into the piece class. And this
yeah.
constructor would also take as input like a Boolean dead. Right? That could be an option. And now that I overload it,
yeah.
I can choose which one I use in my superclass. I could also put here true as my other argument. And then it's overloaded. But actually, if I don't do that, there is another way I could do it. If I don't
Yeah.
overload my constructor, I could also say right afterwards, just if I want it to die right after I do it, I can just say kill, which if we remember the kill method inside of piece, it just sets that to be true. So I could
Yeah.
also do this. But actually, by the design of how I did this, I don't want it to be possible to use the
Yeah.
constructor to kill something. Because why in the world would you want to create a piece which is dead as soon as you create it? That's kind of useless. So for that reason, I don't actually include that in the constructor. That's a design decision because a lot of the time when you make a program like this, you want other people to read the code and not be able to screw up. Right? Like you don't want somebody who makes, let's say, an extension of this chess game to accidentally make all of the pieces dead as soon as they're created. Because, well, that would be a little bit silly. So for that reason, I don't even give them the option to put that in the constructor. And that's more your design decision. That's up to you. You can also add the Boolean as an argument. And as an additional note, see how isDead is private there? Well, I actually can't touch it. So I can't say that isDead is true. If I just try to type isDead equals true now, it's not going to work because isDead is private. I can't even type. isDead is true. See, does that work? Well, no. It says isDead has private access in piece. So, impossible.
Yeah, I understand what you mean, but here this is a very specific case where it doesn't make sense if we just make that to be true. But actually, there might be some other cases where we may have different, situation where we want to set the properties in a different value. So that's why I'm asking this question.
Of course.
How we could make another, instantiation to use super to have a different, values for the properties.
Yeah, and in that case, we want to overload our constructor by having a different copy of our constructor with different arguments. And if we
Yeah.
wanted to be very fancy, what we could do is we could take away public. So instead of saying public piece, I could just make it non-public. This means it will be less accessible. So random people can't use it. And here I can have a Boolean dead, right? And then here, instead of saying isDead equals false, I can say isDead equals dead. Now, this constructor is not public, so not everybody can touch it. Or you can only touch it in some cases. But here now, in my subclass, I can also type true. And this way, I have access to this field in a way that's more protected, so random people can't mess with me. And I can still change the value of this field like this.
Yeah, okay, got it. Thank you.
Yeah. And then, of course, if you don't have a private field, you can also just set it. So if this was public, I could just set it normally. But in my case, it's private, so I can't do that. Now,
Or should we set it to be protected?
yeah, we could, but protected actually is to do with something else. Protected is an access modifier which still lets stuff access it. It's slightly more permissive than having no argument at all. So if you look, I can actually probably pull up a table for you, and then that should make clear the arguments. So I'd say Java access modifiers. Here we can see what every modifier does and where you can access it. Here. So the default one with no arguments is actually more restricted than protected. Protected says subclass yes, but package no. So what that means is if you extend a class outside of your package, you can access protected fields. So if I have a second package and I extend piece, a protected field will let me access it even though we're outside of the package. That's kind of the difference between protected and default. So protected is about subclasses. Protected lets any subclass access your field, but if you're in the same package, the default is actually more secure.
Okay.
Yeah. So here again, in piece, we have one more problem with pawn, and that's that our abstract methods are not defined. Because we know that in an abstract class, having these abstract methods is defined as methods which are not defined. They need to be defined, right? If it's abstract, we're saying every piece must define this method. And here, for that reason, we're having this red underline. It says class pawn must be declared abstract or must implement the method move, right? Because by the definition of an abstract method, it has to be implemented in pawn. So if I hover over this implement methods, it's going to automatically put these two methods into my class. It's going to say that I'm overriding move, because move is abstract, and I'm overriding get symbol because get symbol is abstract. Right? That's why we have those abstract methods. It's so that we can have these methods. Now, I'm gonna try with get symbol first. So to put our symbols, I have a nice little emoji system for it. I use the emoji for the chess piece as my chess piece. But our emoji will depend on whether it's black or it's white, because, well, we can't return the same one for black or white. So to do that, I'm going to do a check for side. Now, we know that the side is a property of piece. Is there some way I can access this side, especially, what if it's private, right? Is there some way I can access this side from pawn? Because if I just type if side, it's red, it doesn't let me do it. So I have to use the getter here, even though I'm extending the class. Does that make sense, right? Like it's private, which means even when I extend the class, I have to use the getter. So how can I do this? How can I work with this side if it needs a getter from my subclass?
Can't we use it the same way?
Yeah, exactly. It's just a getter. It exists, but we have to call it like that, if get side. And now I have to say, equals, let's say side dot black. We're going to return the black emoji, and I'm just going to copy paste the emoji in from here because it's hard to type it on a keyboard. And I'll say return this emoji for the black chess piece. Right? And now else, I will return the emoji for a white chess piece. Return this. And now I have it returning the emoji for a white pawn if it's white and a black pawn if it's black. But there is actually a short notation. Does anybody know how we could do this in one line? This is not to do with object-oriented programming. This is just a bit of a Java trick for you guys. Does anybody know how we could do a one-liner of this? Return if else? We could, but there's actually a very nice syntax for that. And you might not have seen it in lectures. You might not see it around, but it can be really helpful. I could say return, and then I have my condition. So here I'm going to put condition. My condition will be this dot get side is equal to side dot black. And then I'm going to say question mark colon and then a semicolon. And here I can have my two different returns. So the first one will be the black one. The second one will be the white one. And what this notation is doing is it's saying that if this condition, which I specified here, is true, so it's going to say return, and then here it's going to have a condition, and then here I'm going to say question mark, and then here it's going to be value if true, and then colon, value if false. Right? Does that notation make sense to everyone? It's got this condition that the side is black. It's going to return this one if it's true. It's going to return this one if it's false. So this is the black piece. This is the white piece. And that's my way of doing a one-liner for this instead of doing this like four-lined if-else solution. And this notation is really helpful because a lot of the time you might have a return that depends on a simple Boolean condition. And this can save you a lot of lines of code in your implementation. So that's my little one-liner of how to get symbol. Now, when we talk about how a pawn moves, is there any special rule about what happens when it's killing something? Does the pawn move differently if it's going to kill something, or does it move the same way?
Doesn't it move in diagonal?
That's right. So if it's moving in diagonal, it has to move differently than if it's just moving straight. So we need to do that. But also there's another rule for a pawn. Do we know what happens? Like, is there some rule where a pawn moves differently than any other piece, where the pawn has to track its state? By which I mean, when we play chess, there's a certain time when we're moving a pawn where it behaves differently, and it depends on that pawn. That pawn has to remember something. Do we know what that is?
Isn't there like the first move you can move 2 blocks up?
Yeah, that's right. But how can we do this? How can we track that we moved 2 blocks up, or that it's the first move in a pawn class? How can we make sure that each pawn is keeping track of whether it's moved or not?
Could we just have a Boolean?
Yeah, you could just do a Boolean field. Because remember, an abstract class, or something that extends an abstract class, is still just a proper full-on class. There's nothing special about it, and we can just have our fields here. So just our pawn needs a private field. We'll call it a private Boolean has moved. And we can start it off as false here. But to show off how our constructor can work, we can also not do that here. And we can also say in our constructor, after our super call, we can set our fields of our class. So we can say has moved equals false. See, that makes sense, right? Our constructor, here it sets the fields of the superclass, and here it sets our own fields. We always do the superclass first. If you put super as the second line, it's going to give you a compile time error, because sometimes stuff might depend on the superclass. So here it's going to give me a red error if I don't have the super as the first thing. So we have to do our superclass first and our own class second, but we can set our fields in our constructor just the same. And if, like we had the questions before, somebody wants to set it differently, I can also have one which takes as input Boolean has moved, and we can also just set that like this. Has moved is equal to, well, this dot has moved is equal to has moved, right? So we can set our fields from arguments too. And now our arguments here are different from the arguments in our superclass, and that's still a-okay. We don't have to have all of these. In fact, if I want to, I don't have to have x and y. Let's say y for our chess piece is depending on side, right? Like we always create them in a certain y. We can say our y is equal to, say, int y is equal to side equals black question mark. Let's say 1, or yeah, let's say 6:1. That's just saying that the y-axis is always going to be the second line, right? So we can just say like this. But we can't do that, so instead I could just take this and I could put it straight into the y call. Can't I? And then I can just... And look, that is why this syntax is useful. So remember how I said this is a one-line syntax and we need this? Well, in this specific situation, I can't have any lines above super, right? You see how if I put anything at all above super, even if I just do something useless, if I say int x equals 0, or not x equals 0, let's say int useless, and I just declare an int, I can't even do that. I can't even do nothing. Like this line literally does 0 things. I can't have it. I can't have any lines above super. But if I use my special one-line notation for this conditional, I can put this conditional statement inside of my super call. So if you guys ever need to do like an if-else statement in your super, this is how you can do it. Does this use make sense to everybody? I can't have an if-else because nothing can be above super. But I can do this. So is it clear to everybody why it's useful? And does the syntax here make sense to everyone? Right, yeah, I'm saying that if it's black side, it has to be at the second row of black, and if it's white, it has to be on the second row of white. That's just another example why we don't need to have the same arguments as our superclass. This one has an int, a side, and a boolean. It's different from our superclass, and it does a conditional statement in super. So it's just generally an interesting way to do it. All right, so this is a little cool syntax bit, and our pawn class is mostly good. But now we can implement our move class. So let's see, when is it acceptable to move? In fact, our move class is going to be a bit different. I forgot to do one of the abstract methods, is to check if we can move. So similarly to move, we're going to have it be called can move, and it's going to return a boolean. Can move. Can move, and this is just going to check our movement rules for our pieces. And now notice when I added this extra method, pawn class is suddenly red. We cannot use this class anymore because there's an abstract method which is not declared. So now if I click implement methods with can move, then we have our method here that needs to be written. And this is going to check our movement rules. But first for movement, let's just say we're going to do super.move, move. But wait, it's abstract. So what can we do? Well, our move class is actually kind of the same for everyone. So instead of doing abstract, let's just do it regularly. And let's have a move class. Because in reality, when we change our coordinates, we don't really need to do much. And we don't really care for eating because I kind of moved it around here. I'm checking my can move and my move slightly differently. Now my move is just going to say this dot x equals x, this dot y equals y, right? So I changed my move class a little bit. I changed it around. But now, if I keep the arguments the same, I can still override it. Does everything I just did in the last little bit here make sense to everybody? I was able to make this method not abstract, but I can still override it, right? I've changed it around. I've created a new abstract method called canMove to check if I'm able to move. And I've created a method called move, which just sets the x and y coordinates. And now I'm able to override it. Like, even though it's not abstract, I could still override it. And I was required to implement my other abstract method. Are these things all making sense so far? See, the syntax in my subclass actually looks the same. So this one is abstract. This one, not abstract. And it all looks the same. These two, the syntax looks identical when I'm overriding an abstract and when I'm overriding a non-abstract. But in my non-abstract one, I have access to super, so I can say super.move, x comma y. And in my abstract one, I can't do that. I can't say super.canMove. It doesn't exist because there's no method in super. Or I guess I could say super.canMove x, y is eating, but it's going to be red. It's going to say that's not defined because it's abstract. You say abstract method cannot be accessed directly. So this is a difference between it being abstract and it not being abstract. So I can't call super in abstract. Illegal maneuver. I cannot call super for something abstract. And it makes sense why, right? When we say abstract, it's just a requirement that it'll be there, but it's not an actual definition. So I'll do this, and when we move, we do have to do something differently. We don't have to override it. Since it's not abstract, see, our code will still compile if we don't have that overridden. We don't need to override it for it to compile, but if we do we need to do anything differently in our move method for our pawn than in every piece? Again, move is defined in piece as just setting the x and y coordinates to whatever the x and y are. And in pawn, do we need to do anything special? Or can it be the same? Can I just not override this? Can I have nothing overriding move? Or should I override it to behave differently?
Yeah, it's different in the pawn.
And how's it? Yeah.
Yeah, in the pawn, it must be moved in a straight way or vertically way, which is different with the horse. Or
of course.
Yeah. Yeah.
Though that's true, but that's actually not necessarily what I was looking for, because the way I've written this actually in the past, and the way I think it's a good way to write it now, is that move is just a setter for x and y. And then to know if we can move or not, we can use this canMove method. And this canMove method will enforce the rules. So in our game, we can say if pawn.canMove, then move. That would be kind of the syntax I'm looking to use. And the reason for that is that, having the separate move method will allow me to do moves that are not necessarily following the rules in some cases. For example, if I want to reset the game, if I want to move all the pieces back to where they came from, then I could call move, but I don't care about the rules, right? So for that reason, I have this method that ignores the rules, and I have this method that asks about the rules. And also having canMove as a separate one will let me check if a piece can move to a certain spot without actually moving it. So if I have this canMove boolean, I can iterate through every tile on my board, and I can say, if piece can move here, highlight it green. And if we actually look at the final version of the chess game, I have a feature where if you select a chess piece, it will highlight all the places it can move to in green. And for that reason, we use the boolean, right? Does that make sense, why we have these two separate methods? So again, rules are enforced here. And this one, up here in non-abstract, this one just sets x and y. So these make sense, right? The rules are enforced here. This is x and y. Now there is actually something we need to do here, and we were talking about it before. Remember how we said we have a boolean for whether our piece is moved or not? what's the best way we could actually set this Boolean so we know that if it ever moves at all, this Boolean is updated? Is there a good way we can change this Boolean, right? If I'm overriding move, what I could do is I could say that has moved is equal to true after it moved. Does this make sense to everybody? Move normally doesn't have this. My move method normally just changes the x and y coordinates. If I just get rid of that, it changes x and y. But if I undo that maneuver, now it changes has moved. Because no other piece cares about this Boolean. But for the chess piece, it needs to behave the same as every other piece. Behaves the same as every piece, setting the new x and y, but it tracks having moved. So does it make sense to everybody what the difference is here? And why this one needs to differ from the superclass? Here on the right, I have the piece class, and on the left, I have the pawn class, by the way, just so we can see the differences. And if there are any questions, if anything is unclear, it's a good time to ask. Okay, and I'll reiterate it one more time. And if you have any questions, you're welcome to ask as well. It's that when we do super.move, we're changing the x and y coordinates. And in the pawn piece, we need to keep track of whether we've moved before or not. Because if we've moved before, we need to be able to know how many places forward we can move. Now, we need to be able to also write the rules for when we can move. And these rules will depend on a couple things, right? So what rules do we need to follow? The pawn moves only upwards, I guess only away from the side it started on. Then we need to say that it moves 2 forward if this is the first move, and if it can kill something, or it can only kill diagonally. It can only kill diagonally. If it can kill, no moving straight, right? So is there some way we can use all of these rules to implement our move? And by the way, guys, I know that we're not even close to finishing the game. The reason for that is that in the previous session, the Tuesday session, I went really fast and I got through every class and finished the game quickly. This session is a slower one for people who, well, understandably, might have not been able to keep up with Tuesday. I mean, of course, it was super fast, so I don't expect that everybody could keep up with it. For that reason, today's session is much slower. So we will only get through pawn and piece, and then this will explain all of the concepts in a lot more detail. Then when you watch the recording for Tuesday, it should make a lot more sense because all of the other pieces are just reiterating the same concept, right? So today I'm going very slowly through all the concepts with just pawn and piece, and on Tuesday I was going very quickly through all the concepts. But that way, if you watch today's and you understand everything, if you watch Tuesdays as a recording, you could actually see the whole chess game be made applying these rules over and over again with all the different pieces. So hopefully that makes it a bit more understandable. Now, we'll get to questions from you guys at the end soon. I'm just going to write the rules for how this piece moves. We'll say that there's an acceptable difference of y, right? And this is going to depend on whether or on what side it is. We're going to see if it's positive or negative, if it's allowed to move positive or negative direction, depending on which side it's on. So acceptable diff y is equal to this dot get side is going to be black, question mark 1, comma negative 1. So it's saying that it moves positive direction if it is black, negative if white. Now I'm going to say that the int required diff x So if it's required to move a certain distance in the x, will be is killing, or I guess is eating, and then it's going to say 1:0. So what this means is it's saying that if it is killing, if it is killing another piece, it must move in the x direction diagonal. Now we're going to say that if it hasn't moved, then our acceptable difference in y can be double. And for that I'll say times equals 2. So we're saying here, if this is the first move, we double how far we go in y. And similarly, we'll say, well, now we can actually enforce our rules. So we can say that the difference between its current position and the future position need to follow our rules. So we'll say if the absolute value of the current x-coordinate minus the new x-coordinate does not equal the required difference in x, then we'll return false. And we'll say that let's say the int diff x is equal to math.abs, and I'm just rewriting this here again so we can have a variable for it, minus x, but I don't even use it, so I won't. I don't even know why that was in the original code. We'll ignore that. We'll say if the acceptable difference in y is going to be greater than 0, so if we're allowed to move upwards in y, then we will do a return y minus this dot y is greater than or equal to acceptable difference y, and y is greater than this dot y. And this is just saying if it's negative or positive. Else, and here we will return a similar thing, except this one has to be a different direction, and then this one has to be a different direction. So now, this entire method will follow all of the rules for our chess piece, and we have a completed pawn class. So this is our whole pawn class, the same as in the Tuesday session. And then if you watch the recording of the Tuesday session, you could see how all of the chess pieces are made, and it also follows all the exact same context and all the same concepts. So now we can move on to the questions. I can show you guys the final game while I get your questions in, so you know what we worked towards on Tuesday. If you ever want to watch the recording, and if it makes more sense to you after seeing today's session. And here, any questions are welcome now. And another FYI is on Monday, I think Monday, at least I'm planning for Monday, we're going to have a session for Assignment 1 Catch-Up, where we have lots of assignment questions and relevant examples on how to test your assignment, how to fix common issues. So any questions are open, and you're welcome to take the floor if you have any. And I remember somebody before asked about how to test assignments, so I can answer that if you're still here.
So I want to know, like, if our code is passing all the tests from CodePost, what is a good way to like find the new tests?
Okay,
or, like,
so definitely. For that, the actual best strategy is definitely to identify your edge cases. So when you look at your code, do you have situations where you feel like your code is weak? For example, what if you pass an argument of null or an argument of -1? Or you try to put an invalid entry. Let's say where you need to have a fruit, you put an egg instead. You have to try all these weird cases. Or things like having an empty cart and checking out, this kind of stuff. This is all the parts where your code might not work. It's the parts where you feel like your code might not have considered it, where you need an extra if statement to consider an option, or where your for loop might break if you have something super long or something of length 0. These are the kind of cases where a lot of people lose marks, and these are the ones you want to implement. So that kind of makes sense, right?
Because the thing is, with our constructors, she said we shouldn't control for the input that's put into the constructors, right?
Yeah.
So I was having a hard time finding what kind of input we had to control for, because negative numbers at the end for the cost were just printing out like a dash.
Yeah.
And then we don't control for the constructors. What else would there be?
Okay, so if you ever have a for loop where you need to copy something over, for example, that would be an important place to check, because what if does your for loop break when you have the wrong kind of objects? Does the for loop break when you have nulls? Does the for loop break when you have something super huge? That's a good one to check. Then another one to check would be, for example, if you have the deep copy or shallow copy. You remember how we always say that you should use dot equals to compare objects, because if you use equals equals, it compares the references, right? Well, you can take advantage of that by also using equals equals to compare if it's a shallow copy or a deep copy. You can test if you indeed did a shallow copy by checking if all the stuff in the copied array equals the stuff in the non-copied array. Does that make sense?
Yeah.
Yeah, so you want to do tests like that. And then to be honest, for this assignment, there's not a huge amount of catches. Like, as you go further on in your Comp 50 stuff, you're going to see assignments where there's time complexity, where you have to sort things so things can get out of order if you do something slightly wrong. There's going to be assignments where you have big data structures which can have nulls somewhere that can screw you over, or where they need to be in a particular very specific order. And then some weird edge cases can exist where, something goes null when it shouldn't. And those ones are going to have really in-detail testers. This one is kind of more light on you guys. You don't need to do like a 1,000-line tester for this, for sure. It's going to be not that long. But there are these edge cases. For example, like empty lists that are super long, deep versus shallow copy. And there are going to be little details like that, which you can identify just by looking at code post test and seeing, can I make this test a little bit more intense? And you can also identify them by looking at your own code and saying, is there some input I could give myself here that's going to screw me over? And then once you write all of those, you can get pretty close to having a complete, tested piece of code. And then the other tip I give about testers is that you are allowed to work together on testers. In fact, you're encouraged to work together on testers. Usually the best ones are made by groups of students. So I know that on Piazza, just yesterday, there were questions about somebody asking basically the same thing as you. And maybe if you found that Piazza post, you could reach out and you guys could work on a tester together. And you could both work together on testing edge cases, and then maybe bring whoever else you know in the class in as well. And if you all work together, we can guarantee, you know that for a fact, you can guarantee that all your minds together will probably think of more edge cases than you alone. So that would also be a good strategy.
All right, thank you.
Yeah, for sure. And then if you wanted more information on that, I will be showing more examples and more detail on testing, as well as just common issues with assignments on the Assignment 1 catch-up session, which will be announced on my courses as soon as I can iron out the details as to when the best time for that will be.
Okay, great. Thanks.
For sure. And are there any other questions? Oh, can't make that play. Why not? I'm trying to go from DestX 1-3 play. Yeah. So here again, I'm showing the example of how our chess game works and how our pieces move. If you want to see the full implementation of every piece and also the game rules, like when pieces can move, taking turns and stuff, that stuff is all covered on the Tuesday session. So if you want more detail, and if this session everything was understandable, then you can learn a bit more by going to the Tuesday session and seeing the very fast, full-on, every rule of the game session, right? And again, if you have any further questions, now is the time to ask. I'll wait a couple minutes for you guys to formulate your questions, and if there are no further questions, I will wrap up the session. And we can see here our pawn rules are taking place, so this one has to go kill this one. So this one has to go to 2-4, and it takes that pawn. So yeah, if you guys have any further questions, now is your time to ask. I'll give you a couple more minutes, maybe one more minute, and we'll see if you get any. And if not, that's okay. I'm probably making some boneheaded plays here. 1-4 can move to 1-5. No, it's 1-3. All right, well then I'll assume no further questions, and that's kind of how our chess game should look at the end if you watch the Tuesday session. Thank you so much for watching. If you're watching the recording, again, you probably want to watch these out of order, Tuesday or Friday, then Tuesday. And again, Monday, probably going to have a catch-up session. I'm almost certain it'll be Monday. If not, it'll be at the regular tutorial time on Tuesday. But that'll be posted on my courses, so if you're struggling with the assignment, recommend you go to that. And then if you want to learn how to test your assignment better, also recommend going to that. And yes, anyways, the Tuesday recording should be much more understandable after you watch this, hopefully. All right. Have a good day, guys. Enjoy.